Welcome to Code to Scale. This is part 2 of the What is a 12-factor app series. In the last video, we covered code base, dependencies, config, and backing services. Today, let's cover the remaining factors and see what each of these imply. So, build, release, and run, right? Strictly separate build and run stages. Code base is transformed into a non-development deploy through 3 stages. Non-development deploy, I'm assuming this is going to be your production deployment. So there is a build stage, a release stage, and a run stage. Your build stage is a transform which converts a code repo into an executable build known as a build. Using a version of the code that using a version of the code at a commit specified by the deployment process, the build stage fetches the vendor dependencies and compiles binaries and assets. So dependencies is something that we have already covered in the previous videos, where for your service, what you essentially do is you explicitly declare and isolate dependencies. All right, going back to build, release, and run. So build stage essentially is a transform which converts your repo into an executable build. That's it, nothing more. Release stage takes the build produced by the build stage and combines it with the deploy's current config. So in the previous video, we also covered that each deployment will have a separate config as well, or any value which changes between deploys is something which qualifies to be stored as a config. So this essentially is what they're implying when they say that your release stage combines your build stage's output and your configs for the particular deploy environment. And run stage, also known as runtime, runs the app in the execution environment by launching some set of apps processes against the selected release. So process is also one of the factor that we'll discuss. It'll be the next one. But for now, you can assume that you can take it as a face value. Process is something that does a sort of some sort of operations. That's all. All right. So the 12-factor app uses strict separation between the build, release, and run stages. For example, it is impossible to make changes to the code at runtime since there is no way to propagate those changes back to the build stage. This makes sense. Deployment tools typically offer release management tools, most notably the ability to roll back to a previous release. But so this makes sense, right? You cannot do anything to whatever your build stage output is, right? Essentially, the only ability that you will have is to roll back to a previous stable version in case you face issues. So they've cited an example here. The Capistrano deployment tool stores release in a subdirectly named releases, where the current release is a symlink to the current release directly, and its rollback command makes it easy to quickly roll back to a previous stable release. Builds are initiated by apps developers whenever a new code is deployed. Runtime execution, by contrast, can happen automatically in cases such as server reboot or maybe a crashed process being restarted by the process manager, right? So from the POV of the 12-factor app, your developer is only responsible for deploying a particular version. Now, process management is a separated concern, right? This is what they are saying here. 12-factor app uses strict separation between the build, release, and run stages. Your build stage, release stage, and run stages, they are all separate, and they should be as per the 12-factor approach, right? The build stage can be more complex since errors are always in the foreground for a developer who's driving the deploy, right? Makes sense. Cool. So I think pretty straightforward. You essentially are just strictly separating your build, release, and run stages. That's all. Cool. Moving on to processes, which we briefly discussed in the previous section. So processes, what it says is you execute the app as one or more stateless processes. So the app is executed in the execution environment as one or more processes. This is again, I think, coming from the Unix philosophy. But yeah, more on that later. So in the simplest case, the code is a standalone script, right? As many of us would have done this in for any problem that you're trying to solve for. The execution environment is a developer's local laptop, which with an installed language runtime, and the process is launched via the command line, right? For example, if you have a Python script, you will simply do Python then script.py. On the other end of the spectrum, a production. So these they're talking about what happens on a local deploy versus what happens on a production deploy. Right? On the other hand of the spectrum, a production deploy of a sophisticated app may use process types instantiated into 0 or more running processes. So you'll have to have concurrency, you'll have to have instance management, orchestration, all these sophisticated things. But the essential idea is you're executing the app as one or more stateless processes, right? And stateless being the key word here, because you don't want to store any sort of state within the service. Rather, what you would do is you would store the state outside the app, primarily in your backing service, which in most of these cases is going to be typically a database, right? This is what they're talking about here. 12-factor processes are stateless and they share nothing, right? This is an architecture type, a shared nothing architecture type. You can kind of go on the Wikipedia article and read more about it. But what is happening is your processes, they don't share any data between themselves. So these 12-factor processes, they're stateless and they share nothing. And any data that needs to persist, it must be stored in a stateful backing service. Right? Backing service is something which we covered in the part 1 of the 12-factor app series. So please go and take a look at the video. So the memory space or file system of the process can be used as a brief single transaction cache. So caching apparently is allowed in the context of the memory space of the process. For example, downloading a large file, operating on it, and storing the results of the operation in the database, right? This is one example where they see that, okay, there is a single transaction cache that is part of your process. Now, the 12-factor app never assumes that anything cached in memory or on disk will be available on future request or job. Interesting, okay. With many processes of each type running, chances are high that a future request will be served by a different process. This makes sense, right? Because if you want to scale your service or your application, you cannot guarantee that, this kind of request will only be served by this particular instance of the process. Right? Makes sense? Cool. Even when running only one process, this may be interesting. Even when running only one process, a restart triggered by a code deploy, config change, or whatever, right? It'll usually wipe out all local state. So the problem is if you're storing state in your service memory or on the file system of the process, it is extremely difficult to guarantee that this is going to be maintained durably, as in the durability of the information that you're trying to store can be a tricky thing, because of course your service can have faults. You can do a code deploy, you can, as mentioned here, you would want to change something on the config side or the execution environment, it's relocating the process to a different location, all of these things that can happen. I think durability maybe is not the right word, but what happens is the guarantee of the state being present, that is not there. That's why they're mentioning that it'll usually wipe out all local state, which includes both actually memory and file system. That is what they're trying to refer to here. And that is why they're promoting that, if you're storing your persistent data, the data that is to be persisted outside the application, it's much more easier to kind of manage it, right? So, and the only thing that they allow is a single transaction cache, meaning let's say if you're downloading a large file, you want to operate on it and then you want to store the results. So the intermediary or the intermittent things that you would want to kind of store in the service memory so that the processing can be completed successfully, that is allowed, that is okay, right? But what's not okay is storing everything in the service memory or the service file system. That is not allowed. Because of course the reasons that I mentioned, right? There is always a lurking chance that any process that the developer may do, or maybe if the service is crashing, it's restarting, it's going to wipe out everything, and that's definitely not good. Cool. All right, let me just close all these tabs and we'll go to port binding, which is the 7th factor, if I'm not wrong. Yeah, 7th one. All right. Export services via port binding. So this is something which comes from, I don't know if you guys have worked on Tomcat or Apache HTTPD, But this is an extremely tight coupling with the web server container and the web applications, the type of web applications, right? So you only run your Java apps, for example, inside a Tomcat container. So what happens is, because of this binding, this closed coupling, the application is not self-contained, and it relies a lot on the runtime injection of whatever the web server is doing into the execution environment. So what 12 factor says is to kind of enable, what should I put it as, to kind of enable decoupling, to kind of enable this self-contained nature of the application. They promote that the 12 factor app is completely self-contained and it does not rely on the runtime injection of whatever web server you're using, right? And the web apps, they export HTTP as a service by binding to a port. So your service essentially tells it, hey, I want to use this port and I'm acting as HTTP as a service and listening to all the requests that the service has requested. That, hey, for example, if I've written a web server, my service can say I want to use port 8080, and I'll be listening to all the requests coming in on that particular port. So this is exactly what port binding is. Your service, now that it is self-contained, the service itself takes care of, telling that, okay, I want this port where I'll be listening to all the incoming requests, instead of relying on the runtime injection of the web server, right? This is what used to happen in Tomcat, which is the example that they have cited. Right now, if you think about it, this promotes kind of a flexible nature as well. Now that your app is completely self-contained, you can run it anywhere. There is no kind of tight coupling between the runtime environment or where you're, whatever web server container you're using and your web application. Because it is self-contained now, you can run it anywhere now, right? So moving on to the next paragraph. So in a local development environment, they've given an example what happens when you do port binding, right? So the developer visits a service URL like localhost 5000 to access the service exported by their app. In deployment, a routing layer handles routing requests from a public facing hostname to the port bound web processes, right? Pretty simple and straightforward. This is typically implemented by using a dependency declaration. This also is something that we have discussed in the part 1 of the 12 factor app series, so please go and watch that video. To add a web server library or to the app, such as Tornado for Python, Thin for Ruby, or Jetty for Java, right? This happens entirely in the user space though, which is within the app's code. So that's what I kind of mentioned previously as well, right? Because your app is entirely self-contained, it is taking care of binding to a port and telling that, hey, I'm listening to all the requests coming in on this specific port, right? Now, HTTP is not the only service that can be exported by port binding. So nearly any kind of server software can be run via a process binding to a port and awaiting incoming requests. So these are different protocols that they have suggested, and essentially the idea here is your service, no matter what the protocol is, your service is taking care of specifying that, hey, this is the port that I'll be listening to for incoming requests. And this decouples the service with whatever web server container environment you had to specify earlier, right? And this brings a sort of flexibility. Now that your application is self-contained, you can run it anywhere. You just have to specify the port, and voila, your service listens to any type of request coming to that port on any sort of protocol as well. This is what they've said. For example, Redis, right? You specify that this is 6379 is the port that Redis typically uses, and Redis protocol is going to be listening on this particular port. So now your app is completely self-contained. It does not have to depend on, hey, I'm going to run on this environment, so maybe, the environment, the web server environment has to take care of all of this. No, your app dictates everything because it has to be self-contained and flexible. Like, that is the essential idea. All right, okay. Moving on to concurrency, one of my favorite topics. Now, this is where things may get a little interesting. So this is very use case specific. I'll just give you a disclaimer. I personally have worked on apps where I've followed the process model, which is the Unix philosophy. And I have also worked on applications which are deployed in production, serving traffic for millions of users which do not follow this model. However, they are implementing concurrency in a different way. It's not just the Unix process model. It could be a different way where you are still implementing concurrency in an efficient manner, right? So this is some sort of disclaimer I wanted to give. This is not the only way, but this is one way which the 12-factor app promotes, right? Now, concurrency. Scale out via the process model. So any computer program once run is represented by one or more processes. Simple, fair enough. I'm going to take this slow because this I feel is one of the most important aspects of the 12-factor app. Web apps have taken a variety of process execution forms. For example, PHP processes run as child processes of Apache, started on demand as needed by request volume. Fair enough. As your volume grows, your processes also may spawn up, right? Java processes take the opposite approach, with the JVM providing one massive super process that reserves a large block of system resources on startup, with concurrency managed internally via threads. In both cases, the running processes are only minimally visible to the developers of the app. Now, in the 12-factor app approach, processes are a first-class citizen. Processes in 12-factor app take strong cues from the Unix process model. You can go through this link and you can understand what the Unix process model is in depth, but I'm not going to cover it because the scope of this video is not that, right? Now, they've given a brief. So using this model, the developer can architect their app to handle diverse workloads by assigning each type of work to a process type. If you look at this diagram, right, what they have done is, if any kind of web app related process is there, your web processes are separate. If any kind of worker related thing is there, your worker processes are separate, right? But one thing that you notice is there are multiple web processes, multiple worker processes, because this is what the Unix process model describes. Using this model, the developer can architect their app to handle diverse workloads. So basis the type of workload that is to be handled, the process also changes. And because the process is different, what you do is you run multiple processes to handle scale, right? So this is pretty simple. And this will get clear with the upcoming paragraphs as well, right? So let's go through it. For example, HTTP requests may be handled by a web process, right? Web 1 and Web 2 will handle your HTTP request, and long-running background tasks are handled by a worker process. Now, this is what they mean by concurrency. Now, you have different types of workloads, and for different types of workloads, you have different types of processes. And for different types of these processes, you have multiple instances of these processes running. For example, for HTTP requests, you have multiple web processes running. For long running background tasks, you have multiple workers running, right? So this is what the gist of this thing is. They follow Unix process model, which tells that the developer can architect their app to handle diverse workloads. Essentially, this is in gist that different types of works demand that there should be different types of processes. Once you have different types of processes, you can spawn multiple instances of those processes to handle scale. In just this is the only thing that they're talking about, right? Cool. I hope this is clear and I did justice to the explanation. Cool. Moving on to disposability. Oops. Here it is. Cool. So what does disposability tell us? So it tells that you have to maximize robustness with fast startup and graceful shutdown. So the 12-factor apps processes are disposable, meaning they can be started or stopped at a moment's notice. Now imagine that your app, you want to stop it and the app is trying to do resource cleanup and it's taking 5 minutes. Imagine how much bandwidth of a developer is going to be wasted in ensuring that the processes closed are correct, and the resource cleanup is correctly done, and the app is actually shut down. It doesn't make sense, right? So this is what the 12-factor app promotes, that the processes, they are disposable, meaning you can start them up, you can shut them down at a moment's notice. So what this facilitates is, it facilitates fast elastic scaling. Now imagine, right, like this is also interesting. Let's say if your process to spawn up takes maybe 2 minutes or 3 minutes, and you are kind of seeing a request surge, and 2 or 3 minutes is going to be a very long enough time for you, because the instances, they're taking very long to get spawned up, and your requests, they are getting dropped. So now, like, this is like a bad situation to be in. Instead, if you can guarantee that your processes, they are disposable, meaning I only take a few milliseconds or few seconds to start my processes, you can handle scale efficiently. You can spawn instances on demand or basis your request pattern or request volume, and you will ensure that the users have a good time using your service or your product, whatever it is, right? So this is what disposability facilitates: fast, elastic scaling, rapid deployment of code or config changes, and robustness of production deploys. Processes should strive to minimize startup time. So ideally, a process takes a few seconds from the time the launch command is executed until the process is up. So this is the barometer of what 12-factor app promotes, where your process should just take a few seconds. That's it, to spawn up. Short startup time provides more agility for release process and scaling it up, and it aids robustness because the process manager can more easily move processes to a new physical machines when warranted. So yeah, anyways, this is like fine. Okay, now processes, they shut down gracefully when they receive a term signal from the process manager. For a web process, graceful shutdown is achieved by ceasing to listen to on the service port. Now, in the previous port binding section, we discussed that the app itself is telling that, hey, I want to use this port. Graceful shutdown is when that port is freed up and your service is not listening to that port, right? So this is what it essentially means. Now, there is one important aspect that they also mention, which is regarding sudden death, right? So process should also be robust against sudden death in the case of failure in the underlying hardware, right? Now, while this is a much less common occurrence than a graceful shutdown with sick term, it can still happen. A recommended approach, a recommended approach is to use a robust queuing backend. Now, what that does is it returns job to the queue when the clients disconnect or timeout. So imagine that there is a job that your process has to complete, right? And there is some sort of hardware failure. Now, what happens is your queuing mechanism takes care that, okay, hey, this job had to be completed, but it could not because of some sort of failure, so I'm going to add it to the queue. Now, when the service or the process comes back up, the queue is going to see that, okay, hey, there is this service which is now back up, and this can now take my job and complete it. So this is what they mean when they are talking about robustness against sudden death because of whatever hardware failure, right? So now we have covered disposability. Let's go on to dev prod parity, which is very close to my heart because I've got my hand burnt a lot of times because I've seen developers and teams not following this. And it is like one of the most simplest things to kind of establish and do from day one in your company, right? I encourage, if you don't take any learning from this video, just take dev prod parity as something that you have to do and incorporate in your team. What it says is it's extremely simple, like extremely simple and straightforward. As a developer, you have to keep your development, staging, and production as similar as possible. Now, historically, there have been substantial gaps between development, where a developer making live edits to a local deploy of the app, and production, right? A running deploy of the app, which is accessed by the end users. Now what happens is, in a local deploy and in a production deploy, how can these gaps come? So the time gap, right? So a developer may work on a code that takes days, weeks, or even months to go into production. So that's why the local deploy is way ahead when compared to the production deploy, right? That is why you should promote a cycle time of weeks or maybe days or hours. If you have read something like, so there is this book called the DevOps Handbooks. So this book talks about something called a cycle time. And you can go and read about it. Essentially, cycle time is the time from which a developer receives a request, and the time difference between request received by developer and the time at which the developer has delivered the product, right? So this is one way via which how you can close the time gap, keeping the cycle time as minimal as possible. The personnel gap. Developers are writing code, but they're not responsible for deploying it. Hey, yeah, DevOps engineers or ops engineers may be busy with something else. So this essentially can lead to an increase of gap between local and your production deploy, right? Tools gap. Developers may be using a stack like Nginx, SQLite, OS X, while the production uses Apache, MySQL, and Linux. This is a fucking recipe for disaster, right? Don't ever do this. Keep things as similar in development, staging, and production as possible, right? Now, the 12-factor app is designed for continuous deployment by keeping the gap between development and production small. And looking at the 3 gaps described above, make the time gap small. This is what we talked about. A developer may write the code and have it deployed hours or even just minutes later. This is essentially going to keep the gap minimal. Make the personal gap small. Developers who wrote code are closely involved in deploying it and watching its behavior, right? You don't leave it to ops. As a developer, you own the deployment as well. Make the tools gap small. Keep development and production as similar as possible, right? This is straightforward. So summarizing, this is just a summary. But yeah, this is one of the most important things that I feel that teams don't follow, and this is something that I've noticed as a one of the major differences between high performance team and a relatively low performing team, where the gap between their local deploys, stage deploys, and the production deploys is way high. So yeah, this is one of the most important things that you should follow. All right, so now we have covered dev and prod parity. So that's it for the part 2 of 12-factor app approach. In the next video, we will cover logs and admin processes. Thank you so much.